Hi, it's Mrs. Seitz, and we're going to pick up where Miss Frisco left off. So far, you guys have learned three different properties with multiplication of exponents. So we're going to take a look and try out a couple problems together, and then you guys are going to try a couple on your own. So, with this product of powers property that you guys just learned, you're basically collecting numbers that have the same base and you're adding your exponents. So, if you look at the first one, we have 2 to the fourth times 3 to the fourth times 2 to the negative 2 times 3 to the second. So, we have two bases of 2 that are the same. So we're going to write the base of 2, and this rule says that we're going to add our exponents together. So 4 plus negative 2 is going to give me a power of 2. The other one that has the same base is a base of 3. So I have 3 to the fourth power and 3 to the second power. So I'm going to write the base of 3 and add my exponents together. So that would give me 4 plus 2, which will give me 6. All right. And I'm going to leave this answer the way it is right now. You could technically multiply this out to be a bigger number, but just for our purposes right now, we're going to leave our answer as powers. So for question number 2, we're looking for the same base again. So I see that I have q to the third and q to the sixth. So I'm keeping my base of q and adding my exponents together. So that will give me 3 plus 6. That'll get me 9. And then I'm going to bring down my lonely base of r, which will be r to the second. Okay, we're going to do the same thing for number 3. For number 3, we have n to the third and n to the negative 4. So I'm going to keep my base of n, and 3 plus negative 4 is going to give me negative 1. And then remember, we have another n right here that technically has a power of 1 on that. So we would have negative 1 plus 1, which will give me n to the 0 power. In the future, we're going to actually be able to simplify that down a little bit further. But for right now, if you'd ever get anything raised to the 0 power, we're going to leave that as our answer. For question number 4, we have two bases of 7. So we're going to keep our base of 7 and add our exponents again to get 12. For question number 5, we have two bases of 3. So negative 3 plus 4 will give us 1. And then 5 to the 8th, 5 to the second. So keep the 5. And 8 plus 2 will give us a total of 10 bases of 5. And for number 6, we have n to the fourth, n to the negative fifth. So 4 plus negative 5 will give me negative 1. And then I'm going to write down that base of m. In the future, we're going to be able to do something a little bit further with that negative 1, but for right now, we're just going to leave that as our answer. Okay, now with this one, this would be our power of a power property. It's a little bit different. So remember, this is kind of like 4 to the third times 4 to the third times 4 to the third. I think of it like this. If I have exponents that are touching one another, I see two exponents that are in a row, I know that I need to multiply with this rule. So I'm going to do 4 to the ninth power. Okay, in question number 2, this looks like a combination of a couple different rules. So I see the two exponents in a row right here. So I know that I'm going to need to multiply these. So I'm going to have x to the negative 15th. But then I'm going to write down that times x to the fourth. This kind of looks like the rule that we just did on the previous page. So I'm thinking about how many total x's I have for my final answer. So if I had x to the negative 15 and x to the fourth, I'm going to keep my base of x and add my exponents together. So negative 15 plus 4 is going to give me negative 11. For question number 3, I'm going to keep the base of 3. And again, I see those two exponents in a row. So 4 times 5 will give me 20. For question number 4, again, same as question number 3. I see the two exponents in a row. So I'm going to think that I'm going to multiply those together. So keep the 6 and multiply those together to get 6 to the 10th. Okay, number 5 is a combination again, but I'm going to do my power of a power first. So I'm going to get rid of the two exponents that I see in a row. So a to the 12th when I multiply them. And then negative 2 times negative 3 is going to give me a to the 6. And then as your last step, you want to think about how many total a's that you have. So I have a to the 12th and a to the 6. And when I add them together, I'm going to get a to the 18th. Now, question 6 is probably the hardest problem that we have here because question number 6, we're actually keeping that 3 and we are going to be taking that negative 2y and we're going to have 3 copies of it. So what really is happening here is we have negative 2y, negative 2y, and negative 2y. So that's what we need to think about what's really happening. I'm going to get rid of that and I'm going to show you guys what we're really doing here. We're taking that exponent of 3 that's on the outside and we're raising each factor on the inside to that power of 3. So keep that negative 2 tucked away inside that set of parentheses, raise it to the third power, do the same thing to the y, and raise it to the third power. Now, I know you might think it might be silly to keep that negative 2 inside the parentheses, but get in the habit of doing that so you don't make a sign mistake. So the quantity of negative 2 to the third power, y to the third power, would be our answer for question number 6. And again, if I asked you guys to multiply this out, you would keep the parentheses in your calculator and then raise that to the third power. Okay? All right, now let's take a look, guys, at some problems that would require maybe using all 3 of the different properties. So when you have multiple exponent properties being used, this is sort of like my little checklist that I use to help me to figure out what I need to do and maybe the order of the things that I need to look for. So the first thing that I always look for, that last rule that we just did when we were distributing an exponent to each factor using that power of a product property, that's the first thing I always look for. The second thing I always look for is if I have those two exponents in a row, using that power of a power property, when I multiply the exponents together, I get rid of those next. And then my last step is I combine up everything that's the same by adding my exponents together through that product of powers property. So let's try a couple out together, and then I'm going to have you guys pause the video and try out a couple on your own. So for question number 1, you got x to the second, and then we have the quantity of x to the third raised to the third. So I don't see anything that looks like that previous problem. So I'm going to move on to step 2. I do see those two exponents in a row right here. So that means I'm going to be multiplying those together. So I would have x to the 9th power, and I'm going to bring down the x to the second. I'm going to move on to step 3 now, where I'm going to figure out how many total exponents that I have. So if I have 2 x's here and I have 9 exponents or 9 x's in the second set of factors, 2 plus 9, that'll give me my final answer of x to the 11th power. All right, in question number 2, it looks to me like I need to distribute an exponent of 2 to both negative 3 and to y. So I'm going to keep that negative 3 in parentheses, raise it to the second power, y to the second power, and I'm going to bring down that y to the fourth power, but I'm actually going to drop the parentheses because really the only exponent that's hiding on the outside here is a 1, and anything raised to the first power is just itself. I'm going to put multiplication dots in between here because I think that that's going to help me separate everything and keep everything nice and neat. Okay, now I don't see the two exponents in a row in this one, so I'm not going to be multiplying any exponents together. So my last thing I'm looking for is any factors that I might have to be the same. I'm going to be combining them together by adding my exponents. So I can see right here that I have 2 y's here and 4 y's here. So that means I'm going to have a total of y to the 6th power. And then I'm going to bring down that quantity of negative 3 to the second power. This time I'm actually going to multiply it out. So I know negative 3 times negative 3 is going to give me positive 9. And I'm going to copy that y to the 6th power right next to it. Okay, let's try number 3. Number 3, looks like I'm distributing a power of 3 to both the factor of 4 and the factor of n to the 5th. So I'm going to write that as 4 to the 3rd, and then I'm going to write this as n to the 5th raised to the 3rd. Okay, next thing I'm moving on to is, do I see 2 exponents in a row? I do. I see I have n to the 5th raised to the 3rd, so that means I'm going to be multiplying those factors together. So I'm going to get n to the 15th. I'm just going to bring down that 4 to the 3rd. And I know, let's see, 4 times 4 is 16, and then 16 times 4 is going to be 64. So that's going to be 64 n to the 15th for my answer for question number 3. So we're going to try out 3 more, and then you're going to try the last 6 on your own. Okay, so here we go. For question number 4, I'm going to first distribute that power of 2 to the 1/2 and to the n. I'm going to do the same thing in the second set of parentheses. I'm going to do it in a different color though. So I have 6 to the 2nd, and then I have n to the 3rd raised to the 2nd. Okay, so I'm looking next to see, do I have any of those 2 exponents in a row for power of a power? I do right there. So that would give me n to the 6th power. And then let's see here. I'm going to drop down everything else. I'm going to write that as 1/2 to the 2nd, n to the 2nd, and then I have 6 to the 2nd. All right, in terms of things that are the same, I have n to the 2nd and n to the 6th. So that means I'm going to combine them now for a total of n to the 8th power. And my last step I'm going to do right now, let's see, 1/2 times 1/2 is going to give me 1/4. I'm going to think 1/4. And then 6 times 6 is going to give me 36. Okay, and I know 1/4 times 36 is going to give me 9. So all I did is I thought about in my calculator, or I thought in my head, 1/4 times 36 will give me to simplify the factors in front. Okay, number 5. Now, number 5 is a little interesting. We don't have any exponents on the outside. So we really aren't distributing anything here. In terms of what we're going to do, well, here's what I want you to think of. Let's squeeze a 1 in front of both of these. And let's actually drop the parentheses so we can see what's happening. So we really have -1 times x to the 12th. And we also have -1 times x to the 3rd. Let's deal first with the variables. So I know I have a total of x to the 15th in terms of the amount of x's that I have. Now, if I cover up the x's, I can see I have -1 times -1, or the other way I can think about it is I have a total of -1 to the 2nd power. -1 times -1, or -1 to the 2nd power, is +1. And I could just even write that as x to the 15th, and I'd still get the same answer. So anytime that you have a negative sign that's in front of an x, you can squeeze a 1 in front of it to make it a -1 to make the problem a little simpler. All right, how about for number 6? Okay, I'm looking to see if I needed to distribute anything. I do. So inside that parentheses, I see a 2 and an x to the 4th. So 2 to the 3rd, and then I have x to the 4th raised to the 3rd, and then I'm going to drop down that 7 that's on the outside. Okay, so now I'm looking for those 2 in a row. I see them right there. So I'm going to multiply those together. And I don't see anything that's going to be the same because I have a 7 and I have a 2 to the third and I have an x to the 12th. So let's think. I'm going to write down the x to the 12th in my answer. And then I'm just going to figure out what the numbers are right now. So 2 times 2 times 2, that's 8. And 8 times 7, that's going to give me 56. All right, so again, going back, I'm going through this checklist pretty much in my head every single time of distributing, looking through the 2 in a row to multiply, and then combining things up that are the same through addition of exponents. I want you guys to try out 7 through 12 and see how many you come up with correctly. So again, pause that video and see what you do. All right, so for number 7, we would get a final answer of y to the 81st, because again, on this one, you got the 2 in a row. Okay, for question number 8, I would actually write it like this. And then we'd be distributing the 4 to the negative 2 and to the n. So we'd have a total of n to the 6th power. And then in terms of the other ones, let's see, negative 2 to the 4th power and then times 3. And if you wanted to even write that in your final answer, you could. If you simplified it to what it is simplified, you can do that as well. All right, for question number 9, this is kind of like a power of 1 on the outside, so no need to actually distribute anything. If you wanted to break it apart as 4 times y to the third and then 5 times y to the fourth, you can see that we have some y's in common here. So that would be a total of y to the 7th power, and then 4 times 5 would get you 20. Okay, for question number 10, we're going to distribute the 2 to both the negative 3 and the y to the third. You have your 2 in a row, so that means you're going to multiply those together, and negative 3 times negative 3 is going to give you positive 9. Okay, for number 11, nothing to distribute, so I'm just going to rewrite my factors with multiplication dots and look to see if there's any power of powers. Don't see those, so I'm going to start combining things. So I've got 3y's, 9y's, so that's going to give me a total of 12y's. And then my last step, let's see, negative 1/3 times negative 27 is going to give you positive 9, so 9y to the 12th power. And then finally on number 12, hopefully got it, we have to take a power of 3 to every factor in the first set of parentheses, so that would be a to the third. Then we have b to the second, raised to the third, c to the third, and then on that last set of parentheses, we just have a, b, and c. All right, I do see a power of a power. So 2 times 3, 6. Then I'm going to bring down the a to the third, c to the third, and that a, b, and c at the end. Then I'm going to combine everything together by adding my exponents. So a to the third and a will give me a to the fourth, b to the sixth, and b will give me a b to the seventh, and c to the third and c will give me c to the fourth. So hopefully you guys got those right, and we're going to continue practicing these rules. But again, if you need some help, please make sure you reach out, and I will certainly see what I can do to help you.